All right. Sam, are you ready for your presentation?
No, but I'll do this anyway.
I'm sure you will. Take it away, Sam.
Okay, well, let's see here. So I'll do that. I hope this works. Unfortunately, I had some problems installing Zoom, and it continues to be a problem for me. So let's see if I can get this to work. I will now allow that. And let's see here. I am screen sharing. It says the way, and I hope everyone can see the title slide.
We can see it.
Yeah,
awesome.
You can. Thanks.
Outstanding. Like I said, my name is Sam Falvo, and I've been working directly or indirectly with Forth programming since the 90s, as I mentioned earlier. But I noticed that as my programs got larger and more complicated, I ran into frequent debugging nightmares. Things like unbalanced stack depths. You expect 4 things on the stack, but there's actually only 3 things, or worse, there's 5 things on the stack. And so it often led to long nights of very frustrated debugging sessions. And so I sought to basically take a more scientific approach to programming in Forth, which was, just every time I ran into a problem, I would always ask myself, what could I have done procedurally as I was programming it to minimize or even eliminate this particular defect. And it eventually culminated into a thing that I called Ascetic Programming. It dates back to, well, we'll get to that in a little bit. I'm kind of jumping ahead. Ascetic Programming is basically characterized, like all ascetic things, by self-discipline and just being happy without having indulgences surrounding you. So basically the idea here is use the tool that you currently have in a way that allows you to be productive, be happy with what you're doing, sort of thing. It's kind of wishy-washy, I know, but that's kind of the approach that I took. Forth demands a lot of discipline. You are responsible for pointer provenance, for example. You are responsible for validating pointers. You are responsible for controlling shared access to, controlling access to shared resources. And of course, there's the fact that Forth does not have any types, therefore you are responsible for type safety in your software. There are no indulgences that Forth provides of any kind, right? There are no resource management tools, none, 0. No file systems, no dynamic memory management systems, although Forth and its successors do allow for dynamic memory management. There is a separate vocabulary for that. But it's not part of the core word set, right? So it's not baked into the thing that we call Forth. There's no way to validate a pointer because there's no distinction between an arbitrary integer and a pointer, which means that you can synthesize pointers at will, willy-nilly. And there's no isolation between systems or processes, right? And of course, I already mentioned stack parity issues. So Forth is very minimal. By design, by intention. And what I was trying to do with it was a little bit more heavyweight. I was thinking in terms more suitable for other programming languages, is essentially what it basically boiled down to. So what ascetic programming does is, as I learn how to properly write software in Forth, therefore developing my discipline, how do I turn Forth's disadvantages into a competitive advantage? By exploiting the lack of indulgences. So here, this slide probably should have come first. Ascetic programming really started to congeal for me around 2010 or so. And I viewed it then as an alternative to object-oriented programming for maintaining or for writing maintainable software and expressive software. It has zero dependencies. There are no language extensions needed. This is in contrast to things like object-oriented programming or array management and scientific programming packages, where they add to the language by using immediate words or something of the sort. The problem with this is if every time you add a dependency like that, you are impeding on its maintainability. And this is not just a Forth concern. This is also a C and C++ concern, Python concern, Node.js concern. Node.js, in fact, is world renowned for dragging in hundreds of megabytes of dependencies if you just want to write a hello world program. And so the nice thing about ascetic programming was I set out from the start to say, I want no dependencies, because the fewer the dependencies that I have that are related to the act of software development, which is kind of a key distinction, the easier it will be for me to reuse parts of code from one project to another and so forth, right? So that was a kind of a core concept. And since then, I've used it in two programs that I've actually used in the real world. One was a blogging engine that I wrote many years ago now, called Unsuitable. And there's a history behind that name. And another one called Equilibrium, which is a video game that I wrote. Equilibrium no longer runs. It's suffered from bit rot, unfortunately, because some of its dependencies no longer run on modern systems, which kind of exemplifies why I wanted no dependencies. Unsuitable, I just got running not too long ago, again, for the first time. So I might be resurrecting that system in the future. You may be hearing about it coming up, but for now, we'll just move on. Just say that it is a program that I've used it with. So the core tenets, right? I came up with the idea that, entities were this thing to have, right? You wanted something that had identity, but not locality. That is to say, not something that has an address. You can't point to an entity like you can take an address of an object in C++, for example. But with an entity, you can't do that. All you know is that it exists and it has you can give it a name, and that's it, right? Modules are what provides the various state information that you can associate with entities, right? Because they represent concepts and not always types, they frequently map to cross-cutting concerns. So things like aspect-oriented programming and such. Nowadays, you need like special language support for aspect-oriented programming, whereas here you don't necessarily need to. I'm not saying that it covers all use cases of aspect-oriented programming, but it certainly diminishes the need for it because of the ability to be able to write software that spans multiple cross-cutting concerns. And finally, we use relational concepts just about everywhere, right? We replace typing, we replace containment, and we replace static is of relationships, right? Now, that being said, there are dynamic is of relationships that come in quite handy. But for static is of relationships, there's no way to express it in the language. So these are some example modules from my video game Equilibrium. Dimensionable and punctual, for example. I'll let you read what they include here. There's actually many more modules here. But basically, these are cross-cutting concerns, right? So things on the screen typically have a size associated with them, hence they're dimensionable, but not always. Punctual items are things that must do something at some point in the future. Again, not everything does. A title is visible and has a size on the screen, but it doesn't necessarily need to disappear at some point in the future on its own. Mobility indicates things which are moving, right? Again, scores are visible, but they're not moving. Whereas the player and the various sparks and so on and so forth do, right? And from a programming perspective, this is kind of what it looks like, right? So first, you create an entity and you assign it to a variable of some sort because you're going to be referencing that entity for whatever reason in the future. And then what you do is in this block here, is you kind of configure attributes about what this entity is, right? So here we're saying it's sized, it's mobile, and it's visible, right? So from this, we can clearly see that this is something that the user can react to, if not interact with, right? I'll just quickly bring up some code here. I'll zoom in the font size here real quick. So basically the structure of a module is basically some storage that's relevant to however many things of this type, if you want to think of it in those terms. However many things have this concept. In this case, it's statically managed. I don't use dynamic memory management, although you could. I create a number of arrays that include information relevant to the particular concept. And then I've got code, which are basically glorified getters and setters, right? So here's a definition of mobile that includes all of its dependencies underneath. And I'm not going to go into detail how to read and write this. This, again, follows a certain convention, which is related to ascetic programming, but it's not important. But basically, this is a word that basically says that this particular entity is moving with this particular velocity. And it's a very declarative thing. I can call this multiple times, giving the same parameters, and it's idempotent, right? So every time that I declare that something is true, it becomes true. And this is kind of an important thing, right? One of the things that you'll probably notice from this, though, is I'm dealing with like foreign keys and things like that, things which are not addresses. Anything which involves pointer arithmetic, it's all kept in internal, non-exported functionality. So we'll get to that briefly. So, in fact, right now, so modules, like I said, they maintain their own storage privately. They never ever pass pointers into or out of a module without good reason. There are exceptions to the rule, always, right? But as a general rule, you want to keep things free of being specifically bound to a memory address. The entity IDs are used as keys to index private state. Now, in the code that I just showed you earlier, it's very inefficient. I'm basically doing order ON, linear searches through a table. But there are faster ways. Obviously, if you want to use a B tree to index something, if you've got like millions of items, a B tree will certainly work. And then finally, like I mentioned, interfaces tend to be declarative whenever possible. And this helps with maintaining software keeping software in a state where it is easily reusable and it's significantly more unlikely to cause problems if you abuse it. So let's move on to Entity-Component-Systems. Now, these are systems that have become more popular, at least in my perception. They've become more popular in the last couple of years, right? And they're often associated with something called data-oriented programming. Now, data-oriented programming is a recent phenomenon, which is, I want to say, a reaction to object-oriented programming. Basically, they're observing that object-oriented programming has performance-related issues. No one is upset with object-oriented programming with respect to what you can and cannot do with it. The concern is how quickly you can do with it. And the reason why this becomes an issue is monitors today have refresh rates of 120, 240 hertz, right? So we're looking at, we're looking at updating on the order of millions upon millions of pixels with latencies as short as 8 milliseconds or shorter. And when you are pushing your game logic that hard, you suddenly realize, you know what, even for a multi-gigahertz processor, I need a little help here and there. And so object-oriented programming just doesn't deliver the speed with which you can write high-speed video games. So they came up with this idea of data-oriented programming to address that. One way of achieving that is, of course, Entity-Component-Systems. And so when you go out and you Google for these terms, you're going to find that they're conflated a lot. So for now, I'm just going to refer to everything as Entity-Component-Systems. But like Ascetic Programming, there was a number of common features, right? So there are no dependencies, no language extensions are needed. And you can actually find an interesting example of an entity component system in Chuck Moore's own OCAD system that he used in ColorForth. If you go back to watch the fourth day presentations that he used to give, he goes into some detail about how he implements OCAD, and also on colorforth.com if you can find an archived copy of the site. And you'll find that there's a lot of similarities between how he built the software and how ECS systems work. So again, entities are at the core. There's this little bit of difference between how your conventional ECS system treats entities and how associated Ascetic Programming treats them. They're treated as indices into parallel arrays. So that mapping function from an entity ID to some local data structure that I have to go through with Ascetic Programming does not happen here. Basically, if you have an index into a parallel array, you just do a simple array lookup, and you immediately, O1 complexity, have a reference to whatever state you need to work with. Again, this is a performance optimization. It's so that you can do update a lot of things on the screen at once with sub-millisecond precision. It is now there's a website that I include some quotes here, Guru99. I will include this in the chat. Let me go here, chat with everyone. So I'll include the link there. So I'll go back here. Basically, it does a good job describing what ECS systems do. And one of the things that really stood out to me was entities are distinct objects representing an actor in simulated space. It has not actual data or behavior, right? So this is very similar to entities as I've defined it in Ascetic Programming. And this is also the first blow to my ego because, here I thought I was inventing something unique, and, obviously I'm not unique. We're never unique, but we like to think we are. Components, right? These are analogs to what I would call modules. Now, modules have kind of a wishy-washy definition because it depends on the programming language that you're working with. C and C++, for example, do not support modules. They just don't. They support namespaces, which is kind of getting closer to the concept. Rust actually does support modules. Lisps support modules, etc. But not all languages do. So in an entity component system, instead of defining things in terms of modules, they define it in terms of components, which maps a little bit better to your native language binding facilities. So if you have classes, for example, like in C++, your component will probably be a class or two, right? So, okay, semantics, right? There's, regardless of how you define it, they're basically similar to modules. And then you have the system, or systems as the case may be. This is the core of the application that you're trying to build. For OCAD, we're talking about simulating circuits on a chip. For a video game, it would be your input loop and your processing engine, right? Your physics engine, that sort of thing. Basically amounts to whatever application that you're trying to write. So there are some differences between the commonly accepted convention of what an ECS system is and what ascetic programming is. And forgive me, my cat really wants in on this, but a central data structure is typically used, whereas in an I keep saying Associated Press, in ascetic programming, we use distributed state, right? So each module in an AP application maintains its own set of state relevant to its concepts. Whereas in a more conventional ECS build, it's all wrapped up into a centralized data structure. That data structure consists of multiple parallel arrays, just like I've used, whereas the individual arrays represent the concepts that you want to work with, right? Such that entity ID, I, let's say, will index element I in all of those coarrays. So this has some disadvantage compared to what my system uses, in that you're basically pre-allocating all the data that you need, even if you're not using it. So it ends up being a sparse matrix when it's all said and done. And your software is emphasizing imperative rather than declarative functionality. Again, this is a performance optimization. I don't think it's necessarily inherent in what ECS systems do, but when you go out and you look at a conventional ECS software build, you'll notice that there's a lot more imperative functionality rather than declarative, right? So here's an example in Rust of a typical state for a game. In this case, it could be a video game. Right, so we've got structure definitions for dimensions. For punctuals, I use a more conventional name, frame alarm or something like that. We've got velocities, and you'll notice that there's no particular reference to either other objects. There's no, all this is saying is a dimension is a width and a height, and a velocity is a delta x and a delta y. It could be a little bit more complicated than that, but it doesn't have to be. But the big thing is, in your program, you've got one centralized data structure that represents the entire program state. And that is one of the core distinguishing features between a typical ECS application and, say, something written to be aesthetically programmed. But as I indicated, there are also some similarities as well, right? So some ECS systems do use relational concepts, maybe sometimes, if it's fast enough, right? The performance is absolutely king in most ECS systems. So you're not going to be doing joins on tables, right? It's just not going to happen. But if you can get away with it, I've seen, game dev posts that basically say, this is the best way to achieve a problem, and so they will use relational concepts when it applies for them. And also, different modules can be responsible for maintaining their own co-arrays. So although you've got a central store of information, manipulating the code that manipulates that data structure can be distributed among several compilation units, and so you kind of sort of think of them as modules in that sense. So how do these two systems kind of compare, right? Well, ascetic programming, because it evolved out of my very poor developer experience back then, obviously focuses on developer experience, right? I want to be happy when I write forth code. That should be obvious. Whereas ECS systems in most commercial applications today focus on performance. But they share some similarities, right? They both focus on entities. They both use components, although I call mine modules. And they both have, they both can be expressed in terms of relational algebras, although in ECS, it is more often the case that you're just using direct indices into a sparse matrix because it's fast. So let's go back to the things that require discipline for forth programming. How do they compare, right? Pointer provenance. Well, remember that I mentioned that in ascetic programming, Pointers don't cross module boundaries, not unless you have a really good reason for it, right? So if pointers don't cross the pointer boundary, there's no need to manage pointer provenance. So what do I mean by pointer provenance? Pointer provenance is if you have a module A and a module B, and you're passing pointers between them, you know, if pointer A hands a pointer to B, who frees the memory that's responsible or that pointer references, right? Is it B or is it A? And it could be both. It could be either. It could be none, right? That you have to be careful to document that. That is part of the interface contract between A and B. You have to make sure to remember that that is properly documented. That's what I mean by pointer provenance. If you don't pass pointers, that doesn't become nearly as much of an issue. Pointer validation. Again, in commercial systems, you're typically using what they consider to be a higher level language, C, C++, Rust, that sort of thing. With Forth or with Ascetic programming in general, again, you're using declarative interfaces, which means that what you're trying to do is I'm trying to establish a truth. This object is moving at this velocity. That's it. That's all you say, right? How that maps to whatever manipulation of state there is encapsulated entirely inside that module, right? Therefore, that module, unless it's buggy, will always have a valid mapping, or will be able to deliver an error to the user saying, hey, this entity, I have no idea what it is, right? So there's that. Let's see here. I have to read through my cat here. So access control to shared resources, that is handled the same way in both systems, right? In a multi-threaded Forth environment or in a multi-threaded C and C++ environment, doesn't matter. You're still dealing with mutexes, locks, that sort of thing, right? And finally, type safety, right? Small, well-defined concepts in Ascetic programming means that you have small, well-defined declarative interfaces. And that, in turn, because you're dealing with only small chunks of data, helps keep your stack depth small and easily tracked. And in the case of commercial ECS systems, again, type safety is relegated to the programming language. So you don't typically build your interfaces in a way that really heavily burdens the type system or the programmer for that matter. And so I touched upon this a little bit earlier. ECS systems are often conflated with data-oriented programming systems. Like if you Google for one, you're going to find results for the other, and vice versa. There doesn't seem to be, historically, there didn't seem to be a particular definition or boundary between one or the other, although more contemporary articles are slowly starting to make a distinction between them. And I think that's because people are starting to realize that there is more than one way to implement an ECS system. So the reality is that data-oriented programming is one way to implement an ECS system. If you were writing a video game and you say that you're using an entity component system, more likely than not, you're actually practicing data-oriented programming. But I'm going to claim that Ascetic programming, now that I've seen ECS documented elsewhere, and now that I know that I'm not the inventor of the concept, I'm going to claim that Ascetic programming is a form of entity component systems. So for people who want to understand what Ascetic programming is, there's plenty, I can now say that there's plenty of online documentation that you can read up on entity component systems that will give you a good foundation for what Ascetic programming is. And then hopefully this presentation will help illustrate how those tiny differences between Ascetic programming as I see it and ECS systems in the greater universe of software development. And with that, I'm going to end the presentation here, and hopefully I've shed more light than heat. But I get that this has always been a very contentious issue. So yeah, any questions?
Sam, thank you very much. We have time for questions, so please, if you have a question, please unmute and speak up.
Is this targeted for a specific level, like applications level, or game systems in particular?
No. When I first wrote what's going on here? I want to cancel the screen share here. When I first started reading, when I first started developing Ascetic programming, my goal was to develop web applications, actually. Ascetic programming was used to first develop the Unsuitable blog engine. And then I had plans also for developing like a resume, online resume tracking software as well, but I never did get around to completing that. And then I later did use it to implement the Equilibrium video game as well. And that was fun to see that come through, and to see that it could be used for that. More modern software ideas that I had, I was planning on making like a generic graphical user interface library with it. But again, never got around to it. I had many plans, but the fact that I only use this to write 2 programs isn't a very good track record, I admit, but this is a more general technique. I do know that anything which is good for, which you can think of as a simulation of some sort, an entity component system is a good fit for.
You had spoken about that you compared it to object-oriented programming. So how do you think about it now? What's your opinion of it now compared to object-oriented programming?
It's very different from object-oriented programming. It is closer to I mean, it's basically, it is much closer to database programming, actually. Table-oriented programming is another term that has been used in the past. Basically, if you can express basically how do I explain this? In object-oriented programming, you end up with hierarchies of things. X is a type of Y, which is a type of Z sort of thing, and that's a very rigid structure. With ECS and AP, what you end up with is something much more fluid. An entity is currently moving because I say it's moving, but when I tell it, but later on, I could say that it is now immobile. And when I do that, it doesn't just set a velocity field to 0, it actually removes it from the velocity table. And per the tenets of relational algebra, that means that I now have a way of saying that something is something else and something is not something else. Whereas in object-oriented programming, you can only say something is something else, if that makes sense. And
it makes sense. But I was thinking, like, I'm also used to doing SQL on the back end and having like this this significant like table schema where you have a kind of one table or record owns other tables. So in other words, I'm asking, are you replacing the complexity of object-oriented inheritance? Are you replacing that with just a complicated schema of tables that's relational?
I think for applications have a certain amount of irreducible complexity. So given that as a core tenet, I think that will happen one way or the other.
Yes.
Yeah, ascetic programming is not intended to be a replacement for all forms of object-oriented programming. Like I probably would not use ascetic programming if I'm writing software in Python. It's just not a natural fit. Whereas for something like Forth, which does not have innate object-oriented handling functionality, something like ascetic programming is a much better fit.
Okay, thank you.
Yep. Cool. Well, if there are no other questions,
Sam, thank you very much. Could you please email me your slides for posting on the SVFIG website?
I will try. I tried to generate PDFs of the slide deck last night, and it failed spectacularly.
Was your cat trying to eat your mouse?
No, but it is a trackball, and she does like to sit on it. So I like to think of it as incubating it.
Okay, Stephen, I have a note here from Kevin that you would be willing to say something in regard to importing some boards with Klaus's software on it. If you're willing to do that, now would be your time. So please unmute and inform us.
Okay, Klaus has expressed the he said he was going to send at least one board, but I think he sort of expected people to contact him and ask for another board. I don't know if anybody has contacted Klaus and asked for any other board. I was hoping that we could take advantage of Klaus's system and that, you know, we could get a group of us to, you know, work together on his Forth system and see what we could do with it. So he didn't really tell me that I was going to be put on the spot like this. I was under the impression that that Klaus was really sort of handling that. Anyway, I figure, you know, however much the board costs, you know, 10, 20, 30, whatever it was, it'd be worth it to get a board going with Klaus's Forth on it.
Yeah. Well, you know, that brings up the question, you know, are people interested? If there isn't any interest now, then nothing needs to be pursued. So let's keep that in mind for next.
Is anybody interested? Brad, you've got
If I had infinite time, but I'm unfortunately just drowning in other stuff, so I worry I wouldn't have the time at the moment.
Okay.
All right. So what we'll do is be in touch with Klaus if there's anybody that's interested. So that's the way we'll handle that. Yeah.
Hey, I'm going to see if I can drum up some interest from another avenue. I'm on the Electrical Engineer Stack Exchange. I'm going to just put a message on there, see if anybody wants. Anyway, so okay. I'm gonna try other. So there's still. I'm going to say you've got maybe another few days. If you change your mind.
Okay, it would be important when advertising for this that you'd have more information about the board and the version of Forth, and so that may be something that encourages purchase and exploration. So that should be part of your pitch. All right. Well, I want to thank everybody.
you.
I want to thank everybody for participating today. We have time until noontime. So what I propose to do, and if this is okay with Brad, is leave the connection open for random access, as we used to call it. Brad, are you available for time
I
to keep the
can stick
connection open?
around. I believe to leave the connection open, we don't actually need the host to stay here. I was going to pause the recording. Does that make sense?
Yes, please end the recording.